Hello and welcome to Deep Learning Leaders. My name is Eric Landau and I'm the CEO and co-founder of Encord, the data development platform for AI teams. I'm thrilled to be joined today by Adrian Macneil, co-founder and CEO of Foxglove, who's building the observability stack for physical AI. Thank you for joining, Adrian.
Thanks, Eric. Thanks for having me.
So I want to get into Foxglove and robotics and physical AI because there's a lot of very fun stuff to jump into there. But before we do, I'm actually very curious on your background because I think you've had a very interesting trajectory to being a founder in the physical AI space. I saw that you were one of the early engineering leaders at Coinbase.
Yes.
I'm quite curious. You know, the early days, probably before like the crypto craze and all the hype that came in there.
Yeah.
What was it like? Joining this, probably I would imagine like a scrappier startup at the time, and the journey from there.
Yeah, Coinbase was sub 20 people when I joined. I think I was about the fourth engineering hire.
Wow.
Incidentally, so was my co-founder at Foxglove. So the two of us actually were early, and four of the people at Foxglove were there in 2014 at Coinbase. So a lot of us have been working together for quite a while now. But yeah, my co-founder and I met at Coinbase back in 2014. This was kind of just coming off of the first really big crypto bubble. I had done a bunch of work in sort of payments and things like that beforehand, and I got sort of quite excited about Bitcoin and this idea of like programmable money. Joined Coinbase when Bitcoin had hit like $1,000, and I think by the time I left Coinbase, Bitcoin had fallen to about $150 or something a piece, and I was like, this Bitcoin thing is not going anywhere. Clearly, so it was kind of that was followed by the first, I guess, big crypto winter, really. And that is what ultimately my co-founder and I at Foxglove, Roman, we spent a little bit of time looking at startup ideas actually back in 2015, and then he'd done a lot of robotics and stuff in college. Eventually ended up joining Cruise, the self-driving company, early 2016, and shortly thereafter convinced me to join. And so we joined sort of Cruise very, very early on as well. That was sort of 30-ish people at the time. And, a couple of test vehicles, couple dozen engineers, mostly of, ML and robotics engineers, not a lot of people that had the background in infrastructure and data and scaling systems. So at the time, 9 years ago, had no sort of experience previously working in robotics, but had a lot of experience in infrastructure. And that worked really well, actually. Like what we found, especially at early self-driving industry, is that there was really no playbook. And there was a lot of just figuring out, how do we take these concepts of things that exist in the general infrastructure space, like CI/CD? Okay, we know how CI/CD works for servers in a data center and VMs that you can just like delete and recreate. We don't know how CI/CD works when you're deploying to like a physical vehicle and you need to deploy like tens of gigs of map assets and and like you're not just going to deploy Kubernetes on your vehicle or something like this. So there's a lot of just kind of figuring things out from first principles. And so yeah, that was my sort of time at Cruise, about 5 years there building the infrastructure and developer platform.
And so it feels like you've gone through many of the hype cycles and winters through your time in startup world. I mean, at Coinbase, how did it feel going through a Bitcoin winter? Did that affect the entire morale of the company, or was the vision clear enough and anchored enough that okay, it doesn't matter like where the price of Bitcoin is, like we're moving this forward?
Yeah, I think that had more impact on me looking back at it, right? Like about like a third of the company left Coinbase in 2015 because a lot of the sort of the core group of true believers that were, just like die hard into Bitcoin. And then there were those of us who wanted to work on something that seemed to be having impact. And at the time, it was a real struggle, getting people to even adopt Bitcoin, and wasn't really clear, like, the use case. There was a lot of talk about, people are going to be using Bitcoin to buy coffees and things, and that never materialized. So I sort of, I guess, burned out relatively fast there. But looking back at it, that really sort of primed me for these future kind of, like, all technology goes through hype cycles. Bitcoin's kind of the most extreme version of that, right? But like self-driving cars started going through these hype cycles. Robotics go through these hype cycles. And so that really primed me, I think, for the rest of my career, looking back at that, and at the time being so sure that crypto was going nowhere and Coinbase was going nowhere. And then realizing that no, you just need to like stick through it, and these things go in
Mm-hmm.
cycles, they come in waves. You need to just like have a core foundational belief based on
Yep.
first principles and not sort of get too swept up by the hype cycles. The other thing is that the companies that do that and sort of create something from first principles don't they tend to like be category leaders, right? They tend to not
Yep.
be they were there first, and then a lot of other companies kind of jump on the bandwagon, but they end up being much smaller companies than the ones that were kind of catching the wave before it formed. And so that was really that has shaped a lot of my thinking, I think, going into sort of the self-driving space and the ups and downs we had through self-driving. And then ultimately what sort of caused me to start Foxglove in 2021. Ironically, 2021, all the VCs were like wondering why I wasn't starting an NFT crypto company, because like
Yep. We had the same. Yeah.
everyone was like stoked about NFTs and things. Having seen basically what was possible in autonomy, having seen that, hey, we can make a car drive around San Francisco with no one in the front seat, I was very convinced that there are a lot of other areas of the world that could be automated. Why do we have a self-driving car and we don't have a self-driving tractor or a self-driving forklift or a self-driving lawnmower? Like these are all things that are way easier to build than a vehicle in San Francisco, or way easier to automate. So again, that kind of came to that like first principles thinking of like, well, obviously this is going to be a big wave. It cannot be successful without good developer infrastructure. Good developer infrastructure doesn't exist because we built it from scratch. Everyone that I talked to at Waymo and Tesla and Aurora and Zoox and Uber ATG, and everyone had built the same stack as well. So we knew that there was this kind of missing developer infrastructure layer. And I think tying it back to the Coinbase thing, I guess I had that conviction that like, who cares what anybody thinks? Like this is like, it
Right.
seems clear enough of a case to be made.
There's a lot in there to unpack. I always think back to this. I think it's like the Gartner technologies
Yeah.
where it
Yeah.
goes up the hype cycle and then down into winter and then to the slope of
Right.
enlightenment.
The trough
And
of
it feels
sorrow or whatever.
the
Yeah.
trough of sorrow. Yeah, it's also the same for a startup. Yeah, you always go through a trough of sorrow at some point.
Yeah.
And it feels like self-driving is starting to hit this slope of enlightenment. So it went through that
Yeah.
whole decade cycle where it's very hot in 2016, 2017, and then there's a big winter. But now people that kept on going at it, Waymo and companies like Wave here in the UK,
Yeah. Yeah.
they're starting to see the real production use cases and like the light at the end of the tunnel. I'm curious, like for the other parts of physical AI. So some of the things that we're seeing now are in a lot of like robotic foundation models and VLAs. It kind of begs the question, like, are we at on the first level of the hype cycle? So is a
Yeah.
winter coming after this? Or is there some reason to believe that we can just kind of continue to extrapolate forward?
Yeah, I mean, without a doubt, a winter is coming. It's just like when is and this is true of the financial markets too, right? If you know
Yeah.
when, people will keep predicting recessions, every year for the past 50 years or whatever.
Yeah. Eventually it happens.
And then you look back and like, oh, they were right. Okay, but you missed the 8 times they were wrong, and if you'd pulled your money out, you would have missed out. So, like, without a doubt, we're in the early innings of physical AI. At some point, a little bit of trough of reality is going to set in, and I would say the areas that most remind me of the early self-driving right now. And this is not saying that they're bad long-term bets. It's just that like we're very much on the early sort of discovery phase. And I think robot foundation models you mentioned, there's a lot of excitement about robot foundation models now, and robot foundation models are going to be hugely impactful. And some of them are very close to production, like Wave you mentioned, for example, are essentially doing an end-to-end architecture like this, sort of AV 2.0 they call it, and they're close to productionizing foundation models. And then there's a lot of other people that are creating like very impressive demonstrations, but are quite far from sort of that actually being a revenue generating activity. The other one is humanoids. Humanoids are also, again, very like strong long-term bet. Humanoids reminds me of self-driving sort of 2017. Like
Yep.
right now, it's just the broad public seems to think that they're coming like next summer kind of thing. And it's like, no, this is going to be a little bit longer than that. They will be hugely impactful. It's just that, you've got to sort of be realistic about where we are in the deployment curve.
Yeah, definitely. And one thing as well that you mentioned was developing the stack for these things that just don't exist. One thing that strikes me is in the early innings of a technology, it's very difficult to know where the stack will consolidate and what parts will be one component versus factorized into modular components.
Yeah.
How do you think about, as someone that's developing the stack of where the remit is for you guys, like, and where the boundaries are, where there's complementarity. What is the kind of thought process behind that, given that it's quite uncertain at this stage?
Yeah. I think the stack is more clear than people give it credit for, but only to like it's a relatively small group of people that know that, I guess. So the analogy I draw is to the early sort of SaaS industry, basically. If you look back to kind of the early 2000s, you had a bunch of companies that figured out how to run websites at scale. So you had, Yahoo and Google and Facebook and Amazon and eBay. Everyone kind of figured out, like, how do you run a website at sort of web scale? And they had to basically do it from scratch, and they're racking servers and they're building all of this sort of infrastructure stack themselves. And then if you look at the sort of second half of the 2000s decade, that is when like most of the big infrastructure companies were founded, infrastructure and observability. So all of your kind of Datadogs and Splunks and New Relics and all of your Heroku and AWS and all of your Twilio and SendGrid and just all of these infrastructure companies really got started in this like 5-year period. And they took a lot of the lessons that had been learned at the big companies and sort of commoditized them, democratized them. They made them available to everyone else. And then after that, from 2010 onwards, that's like the last 15 years of SaaS explosion history, right? And so I think that's very much where we are right now, where a lot of the technology that was developed in the 2010s for self-driving is very broadly applicable to agriculture, to drones, to logistics, to manufacturing. There's a lot of similarities in the way that you just like approach building autonomy. It's just not a super well-known kind of technology stack yet or skill set or things like that. There are a lot of engineers that got trained at the AV companies now that are out working at these robotics companies. Relatively few of us building the kind of infrastructure layers. But I think there is a stack there that exists today at, let's call it, the top 5 AV companies that is not accessible to everyone else right now.
Is there any dependency on the end architecture of the system? So, there's obviously this debate about end-to-end versus modularized systems and, all these kind of bespoke feature engineering. Do you see like the fundamental elements of the stack are agnostic to those design decisions, or is there is there adjustments and modifications that you need to make as a function of that?
There is for some areas of some parts of the stack, and there aren't for other parts, right? So like Foxglove today is primarily focused on observability. So this is like gathering data from the real world, from your robots, multimodal data. So there's usually cameras, quite often there's LiDARs or radars, sometimes there's GPS, other types of depth sensors, just like a lot of different sensor data. And then logging that, sometimes sending it back to the cloud, but often logging it locally and only selectively uploading to the cloud because you're deployed in like a factory or a field or something with terrible internet, and then bringing that back and analyzing it and understanding like what's going on with my robot, what's going on with my fleet. A lot of that sort of like fleet management, fleet observability, and debugging looks quite similar regardless of like at the end of the day, you've got a robot that's got some sensors on it. And some decisions are happening. So a lot of the way that you think about logging from the robot and collecting data from the robot doesn't really change. We do see a lot of change sort of post that, like how you're going into the actual robotics development. And robotics development has shifted massively in the past 2 years even. So historically, most robotics development was what I would call a traditional robotics architecture. There's sort of a perception stack and then a bunch of hand-selected features of just like how do we model the world, basically. And then from there, quite often a lot of just algorithmic, like hand-coded rules about how the robot should behave or navigate through the world. That started moving in the direction of like, well, we can still keep this like separate perception stack, but maybe we can start training some models on how you would sort of navigate or manipulate the world. And then suddenly there's just been this like enormous amount of research and progress made in end-to-end models where it's just like, no, just throw the sensor data in and have a bunch of good training data, and then we'll come out with some desirable robot behavior. So that has completely upended sort of the development process. And as a result, from the platform side, there's a lot more attention being paid to the data that you're collecting from the robots in the real world that you're ultimately needing to be feeding into your training.
Do you have an intuition of one winning out versus the other? Because I imagine there's a lot of inertia with kind of traditional systems, but if the capability for end-to-end just continues to go up, then that might supersede. But I'm curious to get your view on that.
I think the vast majority of robotics is going to trend towards end-to-end. I mean, I guess maybe we should start from the definition of robotics and how complicated the autonomy is, right? Because there's a lot of like automation type problems that don't really need don't really need that level of
Yeah.
complexity of like an example of this would be John Deere has like a See and Spray product, which is like a sprayer attachment for row crops that basically avoids overspray. So it just like has sensors, like when you're over the top of the crop, like the spray is turned on. When you're doing a big sort of U-turn at the end of the crop, like spray is turned off. Saves you like 50% of the like herbicides or pesticides or things they're using, which is a massive improvement. You don't need an end-to-end model for that, right? You're just like like traditional perception stack is great. Like, you can have some object detection, some classification maybe, and then you're like actuating a sprayer. Doesn't need to be an end-to-end model. But then the vast majority of like navigation tasks and manipulation tasks, and especially the combination of those two is moving to end-to-end because it's just a lot simpler.
And I imagine, so that might be simple, but I'm imagining there's a lot of complexity just dealing with robots in general, and there's a heterogeneity of hardware types and formats. And I'm curious like how you tackled this, wide landscape, like how you think about, okay, there's probably a lot of different use cases and things that I can go after, a lot of different integrations that I can build, and how to like just get data in a format that actually works for like a broad enough swath of customers.
Yeah, definitely. And I think people tend to even underestimate the amount of diversity there is in robotics hardware and things like this. We really tried to focus on the data layer first. So one of the first things that we created at Foxglove was a multimodal data format called MCAP. That came out of, actually wasn't part of the original plan of Foxglove. We had this plan to build the sort of observability, like the visualization and the cloud data management, and then sort of hit the road, started talking to a bunch of companies, and maybe like half of the companies we talked to were using ROS, and ROS has a fairly sort of well-formed logging story and used the ROS bag standard, and so there was some sort of standardization there. For the other sort of half of the companies we talked to, like 5 out of 5 of them would, without missing a beat, say, well, we developed a custom sort of bespoke proprietary log format that we use internally, and we've built up this like entire sort of system around our bespoke logging format, because this problem of just logging multimodal data into a single container, you've got all these different like quite diverse like data feeds. Some of them are very heavyweight things like LiDAR point clouds. Some of them are quite lightweight, like little sensor readings and things. And there wasn't really a good way to store all of this alongside video data, alongside text in one place. And incidentally, a lot of the early team at Foxglove came from Cruise. We'd built the Cruise logging stack before, so we were quite familiar with this problem. So that led to the creation of MCAP, and MCAP is really sort of serves as that abstraction layer. Like you can store anything you like inside an MCAP container. That makes it easy for people to bring in, regardless of what types of sensors you're using or things like that. It sort of usually boils down to a handful of different sort of types of data. Like a point cloud, for example, could come from a LiDAR, could come from a radar, could come from a depth sensor, but you still want to render it as a point cloud.
Is there anything that you would say no to? You look at some kind of very esoteric data type and be like, yeah, I don't know if we're going to do that.
Not really. Like sort of multimodal debugging, multimodal visualization is right up our alley. So I don't think we've kind of come across. We did have to go through a phase of, besides coming up with MCAP, which is helpful for new companies to adopt, and a lot of companies switch to it. But we did still have to create this kind of data loader architecture, because some companies you work with, especially larger ones, just have too much built up around their existing data formats to make it, feasible to switch. So we did have to come up with this architecture that lets us plug in kind of other crazy formats that people have. Probably shouldn't call them crazy, but some of them are crazy. Yeah. I mean, sometimes it's literally like, here's just a zip file with like a CSV in it and like an MP4, and you're like, how do I, how do I sync the timestamps?
And I'm sure there's a lot of complexities as well of just pulling data in the first place from, these are in physical robots in the world. Do you get involved at that level, or is there, is there an interface between the actual edge devices and your platform and solution?
Yeah, exactly. So that's part of our platform. We have an agent that you can deploy on the robot that helps with collecting data from the field. So quite often, like I said, one of the sort of big common challenges in robotics is logging and then offloading of data, whether it's a drone or agriculture or logistics or self-driving car. You're always logging this multimodal data. Is very heavyweight. You've got videos, you've got point clouds, you've got a lot of this like heavyweight sensor data, and then almost universally the robots are deployed somewhere with bad internet. they're either out in the field, or maybe they've got Starlink if you're lucky, or they're indoor, and so you're in like a warehouse environment, and it's a giant Faraday cage, and there's like a maybe 100 megabit Comcast link or something. Like, you just shared between all of the entire facility, and by the way, the facility doesn't want you to like saturate their internet link just uploading log files. So this challenge of how do you get data off the robots is a very common one. We see companies at different stages of that. Quite often the early evolution is like literally just plugging in a flash drive or something, copying files off. That was what a lot of the early cruise vehicles look like. And then it would not be uncommon to go into a company and they would tell me that their primary workflow for getting data from the field is one of their test engineers or operations engineers like SSHing into a robot and like SCPing some files off them. So this is quite a common problem. Sometimes people have built systems they're happy with. Part of our platform is like drop the agent on the robot. It'll actually sort of watch a directory and like lets you log all of that data locally, but not upload it until there's kind of something worth looking at. That might be something that the robot knows went wrong, like the robot is out there and the robot knows that it thinks it had a collision, or the robot knows that it backed into a pallet or it dropped something or whatever it is. Other times the robot doesn't know it did something wrong, but the human operators sort of are pulling up and you're getting a call saying, hey, at 3 p.m. there was this issue, or, maybe it was yesterday, you need to go back and look at it. So quite often you see these kind of like local rolling record, the data is being stored on the robot. And then you've got the ability to go back and say, hey, I just want, I want full resolution data, but only for this like 2 or 3 minutes segment where something interesting happened.
Is besides like obvious times where something goes wrong, are there any other interesting sampling criteria that you've seen where, oh, I just want to see that data because of X, Y, and Z?
Yeah, this is something that we're looking into at the moment, and is kind of coming back to as people are moving more towards sort of end-to-end methods as well, like sampling across your data and finding interesting points in time becomes really interesting, because a lot of the data that you're recording, I mean, take the self-driving car example, right? Like a lot of the data is just driving straight in the lane and is not particularly useful. You've got plenty of data covering that, but then you need a good distribution of events, and you need to start finding these things where I'm like, trying to make a left turn in the rain while there's pedestrians crossing the road or whatever it is. And so that whole problem is quite challenging and can be kind of domain specific as well. Like, do you have the ability to run some kind of like classifier locally? If you can upload all of the data to the cloud, that's a little bit easier problem. At least you can search across it. But like I said, a lot of the time you don't have the ability to upload all of it. So you need something running at the edge on the robot, deciding like, is this potentially an event worth sampling and like feeding back into our data set?
And okay, so I want to actually go back to like the founding of Foxglove. The first question I had actually was, what does Foxglove mean? Like, why did you name the company Foxglove?
Yeah, Foxglove is a wildflower, actually. My criteria for naming, I actually prefer names of companies and products and things that are not sort of literal, because I feel like almost universally the sort of product evolves over time, and quite often you see these companies where the product has evolved so far from whatever the original name is, you've kind of lost that kind of link anyway. So I like these kind of abstract words that you give meaning to. And I went through a lot of sort of astronomy terms and ended up down these botany terms, but of course, like you need to find something that is like easy to say, easy to spell.
Yeah.
If you see it written down, you need to be able to encode. Great name, by the way. Like if you hear it, you should be able to write it down. If you see it written down, you should be able to say it. You need the like lossless round trip.
Yeah.
And you need the domain name, and then you need the GitHub handle or whatever else.
Yeah.
So yeah, that was through a process of elimination. It has no sort of particular meaning other than that it's a sort of wildflower that grows on the side of the road in New Zealand, where I'm from.
It's one of the underrated challenges of starting a company, actually, is getting the name. And it really is underrated. Like, this is very, very difficult to find something that meets the intersection of all the constraints and that everyone likes as well.
Yeah. And it also happens quite early on, and then it just kind of, you get stuck with it. I feel like you're sort of, in a bit of a hurry to find a name. And then, but then, it takes on a life of its own anyway. I was at a conference that we had a couple of weeks ago. I was talking to RJ Scaringe, the CEO of Rivian, and he said Rivian, when they first started it was called Main Street Motors or something. It was just like something like really bland and boring. And then they quite early on figured out they needed a new name, but it was like still very early in the company. They didn't have money for like a branding agency or anything, so they just like went through all of these names, and Rivian ultimately it was like a made up word, but sounded cool to them.
Yeah. And these things always, in hindsight, it kind of always will work because you're just
Right.
going to grow into it and people will know your company. You started Foxglove based off of a wildflower, and
Correct.
you invented this format that allowed you to work with all the different types of robotic formats. Is that why you went open source? Was it always the kind of idea that you'd want to start as an open source company and have that kind of distribution, or was there a debate around that part of the company? So
We actually sort of changed our thinking on this over time too. So we definitely started out with this, I would say, vision like most engineers and developers probably have of like, okay, the perfect dev tools company is sort of like largely open source, and then there's kind of like a paid feature or something like that. It's a fairly
mm-hmm.
common model. So we ended up creating sort of two things that were open source. One was the MCAP logging standard, and then the other thing, our visualization sort of tool, was open source. And the plan was we would kind of have those available, and then we would upsell kind of the cloud data platform. What we realized through the course of the first couple of years of trying to do that is that number one, visualization is just an incredibly complex problem. So basically like 80-90% of the feature requests we kept getting, even from paying customers, like all of their feature requests would be visualization related. And so we're in this kind of weird place where we were spending the vast majority of time building what was supposed to be kind of like a loss leader product, right? And we didn't really have any time to work on the data platform because we kept getting these Viz feature requests and we weren't charging people for Viz. We also found that most people were actually perfectly happy to pay for Viz. Like most robotics developers, by and large, don't enjoy web development, and so we weren't getting a lot of like contributions. Mostly, mostly people just sent us feature requests, and so they actually were happy to pay for that. Maybe 2 years into the company life cycle, we just realized that there wasn't really a way to, we needed to fund the development of the visualization product. And so we ultimately ended up sort of end of lifing the open source version of that. We had always had like a sort of a paid version of the Viz product as well, but it just like kept hitting this weird place where you sort of like arbitrarily keep trying to put features into the paid version and not into the open. You end up with these like really, so just, it became a lot cleaner to just say, no, we're not going to continue developing the open source version. Some people have sort of, continued that on, and have sort of, there's various forks of what was the code base a couple of years ago. But, for our flagship product, we have teams of engineers working on improving this every single day. It works out a lot easier charging for that. And I think also in hindsight, MCAP was a much better open source project for us, right? Like MCAP is it's a data format, it's an open standard. A lot of people do contribute to it. It's very much kind of like much more of a community project. We focus on like, all right, the data format and the logging story is all open source, but the visualization and the data is like a Datadog or something, right? You pay for it and you get access to the product.
When you have an open source tool, you have quite a lot of exposure to many different use cases and people asking for feature requests and esoteric things. Was there anything you were particularly surprised by, like a use case that like, oh, we didn't think that we were going to be used for this? That just comes to mind.
Yeah, I don't think there was anything super surprising. I guess if anything, like a lot of the use cases we were aware of, like obviously is using it for debugging, but also things like using the visualization as like an on robot kind of a locally hosted UI, or an in-car dashboard for people doing autonomous driving where they've got like a safety driver or someone else that's kind of an engineer ride along, and having it. There's kind of these local uses of live visualization as well as these kind of cloud use cases. But we were pretty familiar with that from cruise and from sort of the autonomous driving industry. If anything, the thing that surprised me most was the people that started using it, and this is true today as well. It's not a majority of our customers, but companies that are using Foxglove that actually don't really have multimodal data, and sometimes they are just using like the plot features, for example,
right?
Sort of plotting and the ability to go in and look at like plots and text logs and things, which I had sort of in my head thought, well, there's hundreds of platforms that do that. You can go to Grafana or you can go to Datadog or something if you just want to put in a bunch of time series data and look at it. But yeah, we did find a lot of people that were looking at that and using it in IoT use cases and things like that, but they don't.
Looking to wrap up in a bit, but I'm curious, like, what's in the future for Foxglove? Like, where do you see the company going and the space going more broadly that you're facilitating?
Yeah, I mean, like we said, the big thing in the robotic space is this whole shift in physical AI. I think so. We're seeing like a lot of companies are moving towards these end-to-end architectures. We're seeing this like massive investment in robot foundation models. We're seeing massive investment in these areas like humanoids and things. I think those are all very exciting and trendy. For me personally, I think there's also a lot of kind of unsexy industries that we're seeing, and like manufacturing, for example, I think is like a really interesting sort of place. We're seeing a lot of innovation right now, but it's not getting as much attention. But there's a lot of kind of tailwinds behind onshoring manufacturing, or even throughout Asia and the US and Europe. Everyone is like focusing now, and we have the ability to automate a lot more things. I mean, we're at this point, and I guess tying it back to where we started the conversation, when we started Foxglove, it was very sort of, no one was really talking about robotics, and it was a bit of a unknown about like how long the robotics industry would take to really take off. Now we're at this inflection point that I would say I pinpoint it back to about the start of last year, like start of 2024. There was just this like massive inflection and like interest in robotics and physical AI. It was like a few things driving that, like the hardware finally got to a good place. AI, like the progress in sort of language models and VLMs really started spilling over into robotics. And that also kind of coincided with a lot of this push for, we started seeing a lot of this talk about tariffs and manufacturing and things like that. So there's just been this like huge shift of interest in robotics broadly. And that's awesome to see. Now there's like just a lot more investment dollars going into robotics and physical AI. There's a lot more talent flowing into the industry. And yeah, it's exciting.
Going back to like this Gartner hype cycle of, the hype cycle, and then the trough of sorrow and the winter, and then the slope of enlightenment. So maybe like two questions on that. One is, what is the use case that you think is closest to the actual slope of enlightenment, where there's real production scale and economic effect that we'll see from the use case? And the second is, what is the use case that you think will have the most public ubiquity? So the most chat GPT like presence in the world, and are those different, or do you see those as?
Yeah, for sure. Where we are today, the industries where you're seeing the most actual deployment of robots is in logistics. So these are things like mobile robots moving around through warehouse carrying things. I think Amazon have come out and publicly said they've got on the order of 1 million robots deployed in production, like actively. A lot of warehouses and logistics providers have a lot of robots, just moving packages through warehouses and things like this is huge. Cleaning robots is starting to take off. A lot of this just like material movement and basic use cases where there's not too much manipulation. There's not too much like sort of dexterity required. There's a lot of just like navigating through the world. Inspection and like construction and oil and gas and things like this. So there's a lot of these use cases that you don't hear as much about, but it's definitely where we're much more of that like robotics kind of AI challenges are solved sufficiently, and it's mostly a case of just like scaling these out and dealing with the long tail of issues you run into, and dealing with the operations and that side of things. So right now, those are that's where we are at that end of the spectrum. I think when people are, without a doubt, where we are going to see the most sort of real world awareness of robotics explode as sort of home robots, consumer robots start coming out, because I think that's really where it starts to really play into like all of the science fiction that we all grow up reading and watching, right? You start actually getting, and we have that now with ChatGPT, right? I mean, you have this like, I can just go talk to essentially probably wouldn't call it a robot, but I can go and talk to this AI, and like a lot of the time it has way better thoughts than I do on half of the things I ask it. That exists, but it's still very like virtual right now. Once that starts coming into the real world, you can ask it something and it'll go do a task in your house. And I don't think we're that far away from this. Like we're quite far away from C3PO level, like it can do anything, but we're not that far away from the early home robots, which I would liken to the early PCs, right? Early PCs of the 80s, where you could actually buy these things and they were useful and they were fun, and you could program them and you could start doing spreadsheets and documents and things like that. We're not that far from having kind of home robots that would be able to come in and pick up your Legos and put some things away, and maybe even start making your bed and things like that. And that's going to have a real shift, because most of the kind of robots like that exist in a home today, like a dishwasher or laundry machine or things like, have not really changed much since like the 50s. Right? They've been there. People are very used to them. I think it's going to be this like very rapid shift once we get consumer robots to a price point that and a utility that people start buying them.
One of these robots for my home. So I'm on record. I'm on record.
Yeah, I mean, it's like I think it's 20% of US households already own like a robot vacuum cleaner or something, right? Like this is probably the first use case, but once they start actually putting little arms on them to like pick up things and put them out of the way, that's going to be huge.
Folding machine in my house. So we'll see when that comes out. So I wanted to wrap up with a few rapid fire questions. We've covered some of these already, but I'm curious, like, what advancement in AI are you the most excited about?
Yeah, I mean, it's obviously in the application of AI. Like, we had large language models and we had vision language models. There's been a lot of sort of interest and talk about world models now, but the vision language action models are really like the most exciting part. This is where probably the most challenging of all of these. So this is where you're building single models that can just take in sensor input and put out actions. This is like there's just so much exciting research happening in this space right now.
I agree. Super, super exciting to see a lot of the kind of recipes of LLMs now translating into things that are working in the physical world. If you could debunk one myth about AI, what would it be?
I don't know about if I would call it a myth or not yet, but there's a lot of talk right now about sort of training robots from just like egocentric YouTube videos and things. Actually, I mean, I would say so I say, okay, vision language action models are super exciting. Robot foundation models are very exciting. If you go and talk to, three different researchers, you'll get three different answers on like, can we train them entirely in simulation? Do we need just like a lot of demonstration data? Can we train robots based on just like YouTube videos? But I would say there's a lot of people sort of out there acting as if these are answered questions, and that, yeah, like all we need is some VR glasses or things that we could put on people as they walk around the street in their daily life, and then this is going to like magically teach the robots how to behave like humans. Like I said, I don't know, maybe this is a low confidence belief, but I think that it's probably going to be a mix of all three. But we do need a lot of like simulation, and do need a lot of like actual real world sort of demonstrations that has the movements encoded and not just sort of video data.
So, and maybe just final question here. Like, what does AGI mean to you?
Yeah, I mean, I think we're already there, right? Like, ChatGPT is already basically a colleague or someone that I interact with daily. So I don't know what more we're waiting for there. We basically crossed the Turing test threshold at some point in the past couple of years, and like there was no real celebration or no one, no one was like, "Hey, we did that." So I don't know what more we're waiting for AGI. I mean, I guess you could add like sort of better long-term memory, but even then, sort of like ChatGPT and Claude are both sort of making a lot of progress on memory lately. Yeah, I feel like we're there.
All right, AGI is here already. You heard it here first, folks. Well, thank you so much, Adrian, for your time. I really enjoyed the conversation. Super interesting hearing your journey across, a lot of hype cycles, but to I think the grandest one of all in physical AI, and really appreciate and respect the work that you're doing at Foxglove. So thanks for joining.
Awesome. Thanks for having me.
All right, have a good one.